Hello friends, welcome to my channel. So in today's lesson, I'll be solving two questions which are from the calculus question, right? So we have them on the board here. So I'll start with the first one. We have to differentiate this function 6x raised to power 3 minus 5x squared plus 1 over 3x squared. Let me start by solving here. Solution. The first one. And this function here, we can make use of quotient rule, right? And at the same time, we might decide not to use quotient rule. So it depends on what you want to use. But I prefer not to use quotient rule. The case whereby we use quotient rule is that, for example, if this one was like 3x plus 2 or something, no, when it is more than a term, but it is just a term. So I will not be using quotient rule in this case. I can use quotient rule, but I will not use it in this case because it is just one term, right? So this is how I'm going to go about it. 6x raised to power 3 minus 5x squared plus 1 all over 3x squared. So I'm going to write it this way: 6x raised to power 3 over 3x squared minus 5x squared over 3x squared plus 1 over 3x squared. I know someone is saying wow now. So you already understand what I'm trying to do, right? Then the next thing is now this x raised to power 2. Here we have what x left here. Then here x square cancel x square, and here nothing cancels out, right? So we have 3 here 1 for this, and 3 here we have 2. So here we have 2x for the first term, and here we have minus 5 over 3. Then here we have 1 plus 1 over 3 x squared. This term we have 1 over 3 x squared. This can be written as 1 over 3 x raised to power minus 2. Law of indices, right? So I'm going to write this as this now. This becomes 1 over 3 x raised to power minus 2. Now we can differentiate, right? So remember that this is just like a polynomial, right? So now we can differentiate, and remember that when we want to differentiate x to the power of n, when we differentiate this with respect to x, this becomes n x raised to power n minus 1. So that's what I'm going to use for this. When we differentiate a constant, say c, it is 0. So please let's put it in mind. That's what I'm going to be using here. So when we differentiate this function, so let's say this now is equals to y, then we have the y over the x equals to, this is 2x. Now we have 1 here as the power, so we can write this one will multiply, that is 1, 1 minus 1. That's what we have here. This n multiply what we have here. So that means 1 will multiply the 2 that's already here. Then subtract 1 from that. Minus, now this 5 over 3 here is a constant. It has no x, right? It's a constant. So when you differentiate the constant, it becomes 0. Then plus 1 over 3. Now the same rule applies to this one. That means this minus 2 will multiply what we have here. That is minus 2, then we have x raised to power minus 2, then we subtract 1 from that, right? So n here is minus 2, then we subtract 1, right? And then this n here is minus 2, multiplies what we have here, minus 2. So that is it. Then moving on, we have, this is 2x raised to power 0 minus 0, that is 1, right? That has nothing to do with it. So plus 1 over 3 times minus 2, that is minus 2 over 3 x raised to power minus 2 minus 1 is minus 3. This equals to x raised to power 0 is 1. So we have 2 here. We have minus 2 over 3 x raised to power minus 3. We can leave it like this, or we simplify further. So this can be our answer. Then we can simplify further and write 2 minus 2 over 3 x raised to power 3. This one, this x raised to power minus 3, according to law of indices, is the same thing as 1 over x raised to power 3. Right? So that's what happens there. Alright, so our answer can also be this one, and we can simplify further and we find the LCM. We have 3x raised to power 3. So 1 in 3x raised to power 3, that is 3x raised to power 3, then multiply by 2, that is 6x raised to power 3 minus 3x raised to power 3, 3x raised to power 3 is 1, then times 2, we have this. So this can be our answer. You can simplify further, you can factorize 2, it's common to this time. So we have 2 into 3x raised to power 3 minus 1 all over 3x raised to power 3. And this can also be our answer. So that is the derivative for the first question. And let's move on to the second question, right? So that is question 2. So for the second question, a function f of x passes through the origin. So the origin, we know that the origin simply means 0 comma 0, right? It means 0 comma 0. But before that, we have this function is f of x. So let's write that y equals to f of x. So let's write that let y equals to f of x, right? Now it passes through the origin. So it passes through the origin, passes through the origin. So this implies that x equals to 0 and y equals to 0. As you can see, x coordinate, y coordinate, right? So now that implies that for this one, y is 0 when x is 0. And its first derivative is 3x plus 2. So the first derivative is 3x plus 2. That means this is y equals to f of x. So we know that when we differentiate this, it will be the y dx, right? Is of this function is 3x plus 2. But we don't know what f of x is. That's what we want to find. So to know what f of x is, we need to take the antiderivative. So that means the antiderivative. And the antiderivative is also the same thing as integral. So that means in this question we are going to do integration. So how are we going to do the integration? So what I'm going to do is this now becomes dy, because this is all over 1, right? So dy equals to 3x plus 2 dx, right? So then we take the integral of both sides. So we have the integral of both sides. So when we take the integral of y, it becomes y equals to the integral of 3x plus 2. That is 3x plus 2. And remember that when we want to differentiate x to the n, integrate x to the power of n with respect to x, we have it to become xn plus 1 over n plus 1, right? So this equals to, this power here is x is 1, and the power of these two is x raised to power 0. So that means we have 3x raised to the power of 1 plus 1 all over 1 plus 1 plus 2 x raised to power 0 plus 1 all over 0 plus 1. But let me write this very well so I can see what I'm going to get. So I was saying that the power of this x here is 1 plus, then the x, this 2 has an invisible x with the power of 0, then with respect to x. So, and that's why I added 1 here and I added 1 divided by what I added up here, just following this rule here. Alright, so when you simplify this further, this becomes 3x, so that is 3x raised to power 2 over 2 plus 2x over 1, that is 2x, then plus c. This is an indefinite integral, so we have to put the arbitrary constant, right? So this is y, and we know that y is f of x, right? So now we know that when x is 0, y is 0, so we can make use of that here. So y is 0 when x is 0, we have been given in our question. So that means 0 equals to, the whole of this will give us 0 plus c. So we have that c equals to 0. So that means the constant is 0. Alright. So we can now write the function completely. Y equals to f of x. From here, you remember, right? So that means it is equals to this. That is 3x squared over 2 plus 2x plus c, which is 0. That means f of x is equals to 3 over 2 x squared plus 2x, 0 is gone. So this is the function that we are required to find. If you find this video helpful, subscribe. If you are watching me on TikTok, click on the plus button to follow me. And if you want me to solve more questions on calculus, let me know in the comment section. So see you guys next time. Goodbye.